tasks that were set to them, and there was homogeneity in the use of devices. Well, I believe that this brings a close to my presentation. Thank you very much. And I'd like to thank my students for their help.
¿Terminado? ¿O va a haber preguntas? Muchas gracias.
Thank you very much, Dr. Minguez, for this brilliant presentation. We are all absolutely delighted to see the level of control you achieve. And we are very healthily envious of you for having achieved this very difficult problem. Moving the robot in a remote fashion and using thought. Although, of course, thought may not be the most appropriate word because the technology is somewhat different. But anyway, now's the time for questions from the floor, questions, comments from other speakers, from the audience. This is a good moment to pose the question. I believe there's a question over there. In young users and with a lot of training and with a lot of focus, the signal can be very strong. But imagine that it's a long time, the focus will decrease, and the level of control will be less good. So what strategies have you thought of to find out when the focus, the concentration weakens, and what happens with age? This boy is probably 25, this young man. But what about 30, you know? This will start to go down. The capacity to hold your focus will decrease, and it gets worse with age. Second question, the difference between people used to working with video games and they are used to watching screens and people who've never used a computer for video games. Do you find a difference there? Okay. These are two questions. First question, how it changes during the time people use the device. The answer is that this is one of the most difficult problems because when people become fatigued, the neurological process is slightly modified. There are different ways to go about it. We have a P300 protocol, and right now we have 2 students who are developing learning strategies, not only to use the machine, but also when there are the right answers, they adapt the machine to the new process. And this is the main goal in our work in this interface between brain and computer. The technology right now can be used, but it is also true that as we work for an hour or 2 with the robot, the process changes and the performance changes as well. The second question had to do with different users of different ages. One has to be very cautious We've done this with 5 students of computer engineering who are 20-odd, very young people. In 2-3 weeks' time, we will start to cooperate with the University of Tübingen in Germany. They have patients there, and we will find out which are the limits of this technology. We are all computer engineers, and we want to have a cooperation with people who have experience with patients. So, as I say, we will be using this in real patients. And the other question has to do with the age difference and their habits. The protocol that we use is an innate protocol. I mean, we all have it. And it is true that it'll change for each individual. This is why we calibrate this system an hour before to detect how each person develops their activity. One's got to be cautious. We've done this with 5 students. It works fine, but we need to work on patience. We came here an hour earlier. We measured the EEG. We looked at Carlos's EEG of 16 channels. We've selected 4 or 5 channels with more information of the process under study. Then a training session to see the signal strength at that moment. And hopefully this can be extrapolated to people who are 30 years old. But it needs to be done, and one's got to be very cautious. Finally, and I never thought of it, but you're right, these 5 students who are using the device have been playing video games all their lives. This is something that may change things a little. Any further questions? My name is Alexander Jimenez. Excuse me. During your paper, you gave an explanation about the algorithm used to do the moving or shifting of the chair in the environment in question, in the environment where the person is. My question is about the feasibility of communicating the chair with a navigation system so that the chair can convey the person from one point to another in a city, and which might be the difficulties to develop this technology. Well, there are 3 points of view to answer this question. The first vantage point is the robotics issue. One, a low-level control system moving the chair left, right, and front, mid-level control, what you've seen right now, position in the neighborhood. We can send the chair 6 meters away. It doesn't make sense to go much more than that because the user needs to have control. And finally, the high-level control to send the chair to a large distance. We go for mid-level because scientifically this had not been done. And we've been working on wheelchairs for 10 years. And this is very comfortable for the user to move about in a well-known environment and to have total control over the device. In order to reach this, we've been building the navigation technology for the past 10 years. What you've seen here, it does 4 tasks at the same time. They are concealed. A model is created with a laser. This is why this technology can work in unknown environments. It creates a dynamic planning, generating a trajectory to reach destination. There could be dynamic obstacles or static ones. And finally, it has collision avoidance technology. You may have people going through, etc. This is what we've been doing in the last 10 years. And finally, a little point about your question. I understand that transporting a person goes beyond the brain-computer interaction. The complexity of this problem is the same as the demo we've shown you. But here you would have a sequential task, and you could do this with GPS. We don't use GPS here. It simply recalculates the position of the vehicle at every point in time from the sensors, especially the laser. This has been a problem that the scientific community has been dealing with in the last 5 years. Further questions? I also have a question. The user who was guiding the robot with his thinking was looking at the result of the scanning of the sensors. The fact that you're looking at the result of the sensors, is it not conditioning the response? I don't know how to answer. Usually we use two computers, and the sensors cannot be seen by the user. I'm sorry, but I have no answer for your question. But the fact that you're not seeing your own brain response, and in a certain way, is the answer to the question. Very well then, thank you very much for your brilliant paper. So it'll take a couple of minutes to get the next presentation ready, and we shall continue. Thank you very much. Thank you.